Okay, let's take probably the most demanding of this whole area of resources, which has to do with the idea of energy. I think we tend to assume, especially nowadays, that we use less energy than folks did in the past, and that's totally not true. The amount of electrical demand, for example, is enormous in the United States compared to even 20 years ago. So, and a lot of these are systems we don't even think about. For example, have an Alexa in your office or at home. That's a constant drain on energy, in terms of electrical energy coming in. Plus, you have to have the electrical energy that's used for your internet and Wi-Fi connections that allow this thing to all happen. So, the idea of a modern home that's quote energy efficient is very much a relative concept that 20 or 40 years ago it would be stunningly considered an energy hog. My personal background is as someone who lived on a boat for a while and just finished rebuilding a boat not too long ago that was, electric powered. So everything was done with electricity. And boats, by definition, if they're fairly good size, this was 36 feet, are designed to be entirely autonomous. So, any energy you have in a boat has to be stored on the boat, it has to be generated by the boat, because you're not plugged up to anything else. So I think it's, people who live on boats or build boats tend to be very sensitive to both where the sources of energy are and exactly what uses energy. And that's, when you have this whole discussion, this whole list we've got here on this, in terms of energy sources, if you really want to understand this, live on a boat would be a real easy way to do it, because also you get really hypersensitive to this, or, an RV, for example. So when you're looking at energy sources, the first are your classic examples of non-renewable resources: coal, liquid natural gas, oil, the classic fossil fuels, which, that's accurate. They're basically all, that's all fossilized material that's been compressed into an energy source that then dug out of the ground or pumped out of the ground and then used. Your secondly is what we call biomass fuels. This would be the proposal, for example, in the Big Island, to take an invasive tree they have, the albizia, and basically cut those down and then turn those into, logs that you burn. So what you do is you take the biomass and you convert that into as a fuel. We actually traditionally had this because the sugar plantations here in Hawaii in the 20th century, the energy for the sugar plantation came off of the sugar cane. So when you cut the cane down, you'd squeeze the juice out of the cane. You took that leftover stalk and you threw that into the furnaces, and the fire, the heat that you got from burning that cane generated the boilers and the energy that then, turned those mills to get the cane juice. So ironically, sugar plantations were actually a pretty efficient biomass fuel system because they didn't require any irrigation in most cases, or in a lot of cases, generally didn't require any fertilizers. So, when we talk about things like alternatives to solar, ironically, the plantations from 100 years ago were actually pretty effective. Now, they had other problems. For example, when you burned the cane down, there was arguments of pollution from the, the fires and stuff like that. But, I have a sneak suspicion we're going to revisit this pretty soon. So biomass fuels are where you take something that's usually a plant organism, and you're basically using that as a fuel with the idea that the plant's going to reproduce itself anyways. So that sort of gives you a perpetual source of things that you can use, unlike a non-renewable resource, where once it's gone, the sucker's, it's out of luck for, 40 million years or something like that. Active versus passive solar systems. Passive solar systems, I had those on the boat. I've got some at home. Those are both solar heat, the sense of heating up water, which many of you probably have, and also, of course, the solar cells, the idea of solar panels, which actually generate electricity. These are incredibly inefficient. They're actually very heavily resource hogs. They use a large amount of resources in making a solar panel or even a simple solar cell. So they're not the do-all and end-all. And of course, I would point out that if you're familiar with solar systems, they last an average of 5 or 7 years, and you have to replace the panels. So solar systems are not a way to escape, this idea of resource use. Active solar systems are not really used in a lot of areas, but what that means is basically you use the fact that you've got sunlight beating down, and you use that heat to basically, turn something or heat up something, and then use it. The classic example was actually what they call solar stills, where you'd have water. The heat from the sunlight would hit the water would evaporate and then spin something. That's what we call an active solar system. Versus the passive, which would be, conversion of UV into electricity in a solar panel. Hydroelectric would be dams, where you basically cork up a stream or a river. You then squeeze that water through a very small opening, and the water shoots through it. As it does, it spins turbine blades and generates electricity. Hydroelectric power has been incredibly attractive in a number of locations, especially in North America, due to large number of rivers. There's all sorts of consequences to hydroelectric power. And it says something that in the American West now, I think they've gotten rid of something like 15 to 30 dams in the last 15 years because the amount of damage they were doing by virtue of controlling the water too much was actually causing more environmental damage than the power that you were getting from the dammed up rivers. And then this has been a huge debate that you hear, especially in the American West, but also in other places. The biggest, child right now involved in all this would be China. Three Gorges Dam and the other huge dam projects they're building right now. There's huge questions about the viability of them, even whether they're, if they can build the dams, an idea of just engineering-wise, keep them in one piece, and also what the consequences are downstream of dams. This has been a huge source of politics. In the Middle East, for example, you find that Israel builds dams so they can control the water so that countries around them they don't like won't have access to it. Likewise, countries like Turkey, to get the water before Israel, are putting up dams so they can control the water. The Nile is probably the most famous. Ethiopia or the Sudan, I forget which, I think it's Ethiopia, is planning or putting in a dam. Egypt's already said they're going to bomb it if they finish it because it would control all the water that goes to Egypt, and without the Nile River, Egypt has nothing. So at that point, basically, Ethiopia has a knife up against their throat. So hydroelectric power is real complicated in the sense that it's very much a part of oftentimes regional geopolitics. And so on one hand, it's supposedly a fairly pollution-free way to generate energy, which it's not. But even more importantly is there's huge consequences to damming up a river in terms of it that allows you to control who gets the water, both in the lake, behind the dam, and also in terms of what water you let through down what used to be the river. Geothermal is popular in some areas. I believe Iceland is the only country which has geothermal as the main power system. Other parts of the world have it. Japan's been looking into it, but Japan, like here, has problems with geothermal power because what you're basically doing is you're tapping the hot energy sources underneath the surface of the planet, so the magma underneath. And so what you do is you inject something like water, some sort of liquid down there. It gets near the stuff, it gets heated up, comes shooting up under huge pressure, and then spins turbines. In some ways, it's a similar analogy to hydroelectric. The same process. You're moving fluids around under heat in one case, under pressure in the other. And so in areas where you have access to geothermal, essentially like hot springs or other things which manifest heat, then it can be a good idea. And in Iceland's case, it works for them. Other areas, however, a little more problematic. In some cases, it has to do with perception of place. So for example, geothermal energy here in Hawaii is as much tied to perceptions of the land and the way people use the land and how they should look at the land as it really are in terms of an energy source. Other places like Japan don't have the same trouble with the sort of, ritual or belief aspects of it. But as in here in Hawaii, one of the problems you have is things like earthquakes. Geothermal energy requires that you have, ironically, this sort of weird combination of heat near the surface and a fairly stable land surface. And that's usually not what you find. Any place you find geothermal sources, you're generally going to have a lot of earthquakes and earth moving activities. And that's going to really screw up, drilling a pipe into the ground, because the first time there's an earthquake, the pipe's going to crack and the whole thing blows up on you. So geothermal was seen back 20 years ago as being like the big answer to replacing fossil fuels and other things like that, and hydroelectric. But it hasn't really worked out the way that they intended, because geothermal is a lot more technically challenging than was first really considered. If geothermal were actually the way it was working, then, for example, just the area around Yellowstone National Park, which is hugely active geothermally, could undoubtedly provide a huge amount of the power for the western states to replace a lot of the hydroelectric dams on the rivers. But they just haven't figured out a way to do that safely over extended periods of times. Of course, another one I should put in here, which you don't really think of normally, would be, of course, radioactive in terms of atomic energy plants. And Fukushima is a good example of how those can go wrong. Again, ironically, because of tectonic activity. So earthquakes and resulting tsunamis screwed up and basically wiped out a nuclear power plant. And it would, of course, have the same effect for the geothermal power plant. So these are pretty tricky. The one that's actually, the two that really don't get enough press for reasons that I don't really understand, but the paranoid among you would argue that it's because people can't figure out a way to make enough money out of it. One is what we call ocean thermal energy. That requires the peculiar conditions we have here. You have to have very deep deep water right close to the surface. The OTEC system was originally started. In fact, it was the first test case was actually over at Kailua Kona on the Big Island. I'm down there at the front edge near the harbor. And what they did is they realized that if you actually go into the ocean, since, as we are right here on this part of this island, if you go off a Diamond Head, literally a half mile, you're already in about 1,000 feet or 1,500 feet of water. So in a very short distance from the shore, literally you could go out there on a paddle board in less than 10 minutes. You're already in over 1,000 feet deep of water. And in that situation, what happens is if you go down that 1,000 feet, you not only are going to get the water that's much colder, but it's also going to be enormous amounts of pressure, because if you think about it, it's got 1,000 feet of water pushing down on it. So if you basically stick a straw, if you want to, or a tube or a pipe into that deep ocean, and then you start to siphon that off, so that you release some of that pressure, what's going to happen is that water from deep down is going to get squeezed right up that pipe. It's going to come shooting up there. And that water has two advantages. One, it's enormous pressure, so it's going to come up really fast. So it's just like hydroelectric, if you want to visualize it, except you're not damming anything up. Secondly, it's colder. So you can actually take advantage of the fact that this colder water is then going to interact with warmer water, and you can actually use that heat transfer as another energy source. The OTEC has been hugely successful on the Big Island. They've generated a lot more power. Originally, it was supposed to be a test case for, I think, 5 years. And I saw the plant when they first started up. But it's now been in place for 30-something, longer than that maybe. And the end result is it's still running. They had plans to basically quadruple it. I think they doubled it, but they could basically provide almost all the energy for the Big Island off of about 3 or 4 OTEC facilities. You can do it with all the Hawaiian Islands with very little effort and actually relatively low cost, because there's very little way of moving parts. You're just taking, part of the reality that the ocean's under pressure, and then you're just, finding a way to basically release some of that pressure. It's also ironically non-polluting, because you're just moving the water in the ocean. You're not putting it anywhere else. One of the weird side effects of OTEC, just as a note, is that you can actually take that cold water that comes up to the surface, and then if you use that water, for example, for prawn, for shrimp, you end up with the shrimp love the colder water, and it's also got a fair amount of nutrients. So basically, you can then generate basically food, also algae, off of that deep ocean water that you've already brought to the surface. So then of course, then the water then goes back in the ocean. So it's just it's a fairly clean cycle. And there's a very little way of pollution or impacts over the longer term. So it's one of those would seem like a real obvious situation. Having said that, for most of the world, especially continents, like for example, the continental United States, you don't get deep water till you're maybe at 50 to 100 to 300 miles offshore. For much of the world, you don't have land and then a drop off in deep oceans. So in their situation, OTEC is not as viable unless you actually had like offshore facilities, which are being discussed, because you could actually reuse existing oil drilling facilities, and then just basically turn them into power generators using OTEC. The Europeans tend to look at this more. Ironically, the original invention was here in Hawaii, and it was used here in Hawaii. If anyone want to try to figure out why it's not more popular, go for it. I talked to some of the guys involved in the project, and they just say that they can't get companies like HECO, for example, interested in this, because there's not a way for a lot of people to make a lot of money out of it. This is where it sort of boils down to. Tidal surge energy, that's actually used a lot in Europe, in Holland, also in England, some other countries where you have high tidal surges, oftentimes maybe 10 feet between high tide and low tide. What you get is enormous amounts of water moving in and out of a bay or a river or something. So if you actually can just put, the same type of turbines that you'd use in a hydroelectric plant, and 2 or 3 times a day, or 4 times, I guess, a day, you're going to get the water moving back, spinning those things. So again, it has the advantage that you're not really modifying anything particularly. You're just using the fact that the natural forces are giving you tides, and you're basically taking advantage of that. A variant of that, which they're testing right now off of Haleiwa here, and they actually already are using in Europe to a limited extent, is taking the surge in the sense of the swells that you get in the high ocean, and then just actually having, since that's moving stuff up and down, to use that vertical motion of going up and down in the surge, and you actually use that to generate power. That has huge potential, because like ocean thermal energy, you're not talking about any sort of turbine blades or anything that would impact, for example, marine life. And that has a lot of potential. And again, it's both of these tend to be very durable too. There's not a lot of moving parts. They seem to be a lot more viable, for example, than say passive solar panels covering thousands of acres, which you then don't have available for food, for example, or the last of these, which is wind power, which of course is a huge source of discussion here on the various islands, here on Oahu, especially Haleiwa side. We have these huge wind vanes that are basically propelled by the wind. On one hand, a hugely practical way to generate energy because you've got persistent winds about 300 days a year here. But there are a bunch of consequences to it. Some are just aesthetic, but there's also noise consequences or damage to various, birds and other types of animals. So wind power, was originally, again, by in the 60s and 70s, was seen as the go-to, along with solar cells and solar panels. We're now starting to realize that both of those aren't really near as effective or efficient as they were thought originally. Wind power uses up an enormous amount of resources in producing. If you've ever seen one of these windmills when they're actually taking it apart, and they're not very durable. So, again, you have to replace them fairly quickly. They require constant maintenance versus the OTEC and the tidal surge stuff. So I would, my prediction would be within the next 10 years, you're going to see different energy sources coming to the fore. And ironically, one of the side effects would be here in the Hawaiian Islands, that both the tidal surge or actually the deep ocean swell systems and the OTEC systems really have the ability to free you from, your non-renewable fossil fuels. And in many cases, probably free up space that are currently being used by solar systems or wind power. For the rest of the world, maybe a little bit less, but ironically, say the mainland United States tends to have fairly big tidal surges in a lot of areas. So that could be used. Why isn't it? I don't know. That's not my area of expertise, but it's a lot of this alternate technology is not really being pursued with much aggression because they've got solar systems. They know how to make that work politically and socially. Wind power seems to be a no-brainer. There's huge wind farms being built in Europe, even though there's, again, a lot of consequences to that. So, a lot of when we look at these alternative energy systems, you really aren't, it's again, perception. It's not necessarily, sort of a balance sheet in terms of what makes the most sense. It's based on politics, perception of place, where you can put something versus who can complain about it, and those sorts of other factors. So energy is in many ways, in the use of energy regionally, and where you basically use energy resources and how you use them. Fracking, for example, if you want to look that up, are really fascinating because it's, again, this idea of decision making and perception of the land and perception of resources that really drives it, rather than some sort of really sort of pragmatic database decision making.